Hey, this is behavior-driven development. Had a couple talks from a few years back when used to help facilitate a class in BDD and TDD, test-driven development, behavior-driven development, and got caught back up in that and ended up updating one of the projects, demo projects. And so that's kind of what drives this. And the goal here is to take acceptance criteria specified in a certain way, convert those into acceptance criteria into tests, which makes sense, and then use tooling that knows how to accept that syntax of that acceptance criteria and convert that into stubs that can be then fleshed out, and we can actually build tests against it, and we can run those against our application, components or modules, or we can run it against a running app. Now in this case, I have created a super simple test. This is going to be a behavior-driven development, and this is C# spec flow. And we're going to just test against public search sites. So we're not going to write any C# application here. This is just a way to go exercise some websites. There'll be other talks later about, creating app or testing against libraries, those kinds of things. They're just not ready. They all needed to be upgraded from .NET 4.2 or something. So this is actually using .NET 6. So basically what's going to happen here is, and you might not be able to see this on a phone, of course, but the idea is we're in our IDE, we're going to work in an IDE, we're going to use, and the way this works, SpecFlow actually uses whatever test framework you want. So it's a way of specifying what the tests look like, but you actually implement it using the same technology you use for any of your unit tests for this. So it is a acceptance criteria wrapper for test frameworks, right? So in the IDE, we're going to use XUnit or NUnit or something else, MS Test, and then we're going to use that framework's actually going to run the individual tests, and the individual tests are going to use Selenium to go out and hit search engines. So this is a behavior-driven example using search engine as our targets rather than our own apps, because the search engines don't care if we run a couple queries against them. So the way this works from a generation point of view is that in the IDE, the developer creates behavior scenarios in a feature file. So that in our case, this is going to be Gherkin syntax. This will be given, when, then. Given, I'm interested in buying a car when I go to the search engine and type in car or brand of car, then I get search results back for the car that I searched for, and then I can navigate to those sites by clicking on the link, right? Or something dumb like that. So in this case, the way we're going to build this, the developer is going to create the behavior scenarios in a feature file. This is in a SpecFlow feature file. The SpecFlow extension is then going to read that feature file. And for each feature in the file, it's going to create an NUnit test in a code behind file. And it's going to generate, we can generate the stubs for the given, when, then. So whenever we do something using any kind of DSL, domain-specific language, it creates a scaffold that interfaces from the domain-specific language over to the test framework, the standard test framework. And so in this case, it generates unit tests that then call out to methods that implement the given, when, then stubs, right? So we do given, when, then, but in XUnit, we need a unit test, and all those unit tests really need to call in order, whatever the given part is, whatever the when part is, whatever the then part is. So a single scenario in a behavior-driven definition would actually turn into a single unit test or a single test, and that single test would have multi-phases in it. So the SpecFlow extension is going to create the NUnit tests and create the stubs. And then the developer is just going to code in the given, the when, and the then, and I'll show you examples of that. All right, so that's actually how we do this at design time, right? The design time behavior is to use the plugin and the scaffolding to build out a set of tests. Now, when we actually execute the test, it works as we expect. The IDE will actually run the test. In this case, it's using NUnit because that's what the example does, but it'll use the unit test runner. We actually have the same behavior in Java, right? We use the run framework with DSLs on top of it to give us tests that work at different parts of the lifecycle. So the IDE runs the tests using the runner, which then goes out and finds all the unit tests, which are actually in the code behind files. So the feature files were converted into unit tests that call given, when, then functions So those all become identified in tests. And for each test that's in the code behind, for each scenario, the runner is going to run a test, and that test code behind test is actually going to invoke whatever given there is, whatever when there is, and whatever then, which actually does the validation. So the previous diagram was really about the design part. We do design time behavior and we have test time behavior. So this is the test time behaviors. We will run the test jig. All the code gen tests will run, and the code gen tests will invoke any of the given when then behavior that we created, right? So that's it. There's some notes in here for this about, like what spec flow is and what Selenium is, because we did this for a web test. So I'm going to show you real quick and run this. These are the scenarios I did, super simple in this repo. The goal was to just, you can actually make these as elaborate as you want. I wanted something, this is actually something in a class somebody could do in an hour, right? 2 or 3 people sitting together would actually be able to build out what I'm showing you here in an hour or so. This took me longer because I hadn't coded this in a while. And I didn't have any, whatever. So in this case, what we have is we have scenarios, right? Behavior-driven scenarios. So what'll happen is SpecFlow will actually convert this into the test name, example search with Google. So, and then this will be example search with Bing. And then this one will be example search and title matches. So what I did was, when you write these behavior tests, what you do is you want to keep the syntax the same for as many tests as possible, because each one of these given when thens will become a helper method you got to implement. And if you use the same syntax, you can reuse the same method across tests. So in this case, you can see here, I've got one given, one when, one then, and 2 ands. And if you look, they're all the same. What that means is I had to create 5 helpers to implement these 3 tests, right? So you just be consistent and you have to write less code. It actually means that business analysts, technical analysts can actually create their own behavior suites once the initial set of tests are done. And if they end up needing some new criteria, a developer or somebody else only has to build out that one given, when, or then. So in this case, I have given I search at Google. When I search for the word Microsoft, my search tar should be in the title bar. That's weird, right? Whenever you do a test, a search in any of the search engines, your search terms end up in the title. So in this case, and then I said there should be at least 10 links, right? And so this thing actually supports link counting here, and then I can click on the first link. So these two are the same query, but just with 2 different search engines. I want to make sure they do this, see if they get back similar numbers of results, or at least a minimum number. And then the last one here is actually a table. So in this case, it's given I want to search with a parameter. When I search for that parameter, my search term is in the title bar. In this case, I just skipped the 2 ands. I didn't count the links, and I didn't click on the link to see if it worked, right? So where the other ones actually do a search, make sure there's at least 10 results, click on the first one, navigate to that page. I didn't feel like I needed the extra 2 ands on this here, so no extra code had to be written. SpecFlow will actually read this example table and run 4 queries here, and just only do the one then, whereas the other 2 scenarios all have 3 thens, then, and. So it's super straightforward. You won't be able to read this because the print's really small in Visual Studio, blah, blah, blah. So this is the feature file. And then what happens is that does a code behind for, in my case, N unit here. It could be X unit, could be MS test. It'll generate one N unit or whatever test. So you can see here, example search with Google. If you came back here, you can see example search with Google. So whatever you call these tests, that's actually the scenario name will become the test in your test results. So if I run the test explorer, so I can't make this any bigger, but basically, you can't see it, but basically there are 3 tests here, 2 tests that ran and a suite of tests. And that's because the 2 tests were, I want to search with Google, I want to search with Bing, and then I want to search with a variety of engines with a variety of values that were all in this table. So pretty straightforward. I'm just going to run this, and the main reason so in this case, I did a behavior-driven test. I created a scenario set. I had SpecFlow do a code behind, and for every one of these given when then, I actually went out and had SpecFlow generate a stub, and then there's a method in each one when I search for. given that I want to search for, right? Those terms actually match the words that are in the scenario. So whatever you put in the scenario, that's what the tests, all the helper methods are going to be bound to those terms, right? It's super cool. You just write language, English, well, whatever language you're in, and the test names will match up with your behavior driven. So I'm just going to run this real quick to show you what it looks like. This one actually is going to go out to a couple different websites, run these queries. It's going to go against Bing and Google, and then it's going to do different kinds of searches, verify that there are results out there. And in a couple of the tests, we actually go to the first link that matches and we navigate off. Now, there was one weird thing there, and that was that Microsoft and Google actually return the results in the title bar case differently. Google actually returns the result exactly as I entered it, and Microsoft, in some cases, capitalizes the search term in the title bar. So they're slightly different. In this case, I really just wanted to show that with no code changes, I was actually able to do a set of searches against two major search engines, and that's because actually they use the same field name for their search and for the click button, which is kind of cool, actually, or for the submit, right? So it's pretty straightforward. So that's it. What I would say is, if you want to play with behavior-driven development, you don't want to write any code, and you're kind of interested in web testing or whatever, then go to this project, and it will have these samples that did searches. You can go against any website. You should be able to make a new feature file that describes their test scenarios, and you should be able to do the code build. And because this project already works with the search engines, you know it's got all the right dependencies. Go out and specify what behavior you expect and then test against it. Have a great day.